At this point, you should have a pretty good sense of what the various transforms do. Three.js supports these basic transforms without you needing to understand what's going on inside the code. However, Three.js can't provide every possible type of transform out there, though it tries. More importantly, you'll need to know more about how transforms are coded if you want to program the vertex and pixel shaders in the pipeline. Here's a screenshot of the contents of the 4-arm Object 3D from the Robot Arm demo, using the debugger. You have been using the debugger in your browser, right? If not, please go look at the additional course materials right now and learn more about it. If you dig inside any Object 3D, you'll see a parameter called matrix. It is a matrix 4 with a bunch of numbers in it. Ultimately, this matrix parameter is what holds the transform that changes the object's shape, orientation, and location. When you set the position, rotation, and scale, these all affect what gets stored in this array. This matrix represents all these transforms put together in a tidy package. We can multiply a coordinate, represented by a pointer vector, by this matrix and get a new coordinate. That's honestly it in a nutshell. Any object we make is ultimately represented by a bunch of points. These points are in the object's own sort of space. For example, if we make a cube using cube geometry, it's centered around the origin. We transform the cube's points by a transform matrix to move, rotate, and scale it as desired. A transform matrix is a 4x4 set of numbers. Three.js also supports a matrix 3 type, which almost no one uses. In math in general, a matrix can have any dimensions at all, such as 12 by 38. The 4x4 matrix is the size that the GPU prefers. We can multiply a coordinate by a matrix. This is shown by putting the coordinate to the right of the matrix. The new resulting coordinate is put to the left of the equal sign. The mathematical notation is shown here. The coordinate times the matrix gives this new coordinate. To multiply a coordinate by a matrix, you take the coordinate and perform a dot product with each row of the matrix. For example, the dot product of the first row and the coordinate is this: d1 equals n11 times c1 plus n21 times c2, and so on. The sum of these four terms is the first coordinate of the result. The dot product of the second row and the coordinate gives d2, the second coordinate of the result. After 4 dot products, you have a new coordinate.